Okay, hey there guys. I want to do another video on the negation rules, to follow up on the disjunction and conjunction rules. Doing this will require that we also talk about the contradiction rules. Um, I might do a separate video on that, but at this point, we'll see if we could just get through this without it. Um, okay, so let me go ahead and this over. Okay, so first off, negation elimination. Right. Uh, so again, whenever we're faced with the proof, the first thing we want to ask is what are the main connectives of our premises and of our conclusion. That just helps us get started with what's going to be the first rule that I'm allowed to even do. Right. So if I don't have an and up here in any of the premises, I can't do a conjunction elimination, for instance. And if that's not obvious, then you should be going back to the old videos. Um, at the bottom, I have a conclusion that is just a conjunction. So that kind of gives me an idea that maybe a good way to do this proof is if I was able to find P on its own, find Q on its own, then I can put them together with conjunction introduction, right? So knowing what the main operators of our sentences are is going to give us an idea of how the general strategy to solve this proof. Okay. So first thing I'm going to do is I'm going to just skip a bunch of lines and I'm going to throw my conclusion in right at the bottom as always. And again, I'm trying to think, okay, I want to find P and I want to find Q. And then at the end of the day, so this is an educated guess. I'll be able to get this with conjunction introduction. And now it's just about asking, okay, where can I find P and Q such that I can put these two things together on this line? Well, we already have Q, so that should be pretty obvious, right, from the get-go. And if it's not, then try to just keep working on these. I mean, that's something that that is so just basic to how we're doing proofs, that if you're not seeing that we already have Q, you're not really understanding what the proofs are in general, which I mean that happens. This is difficult to get into, but you definitely, if that's you, you definitely want to be spending a lot more time trying to get comfortable. So we already have Q. Now we just need to worry about how do we get P. Well, think about what premise one is saying. It's saying, well, it's not the case that P is true, right? So it's saying, if this is saying P is false, it's saying it's not the case that P is false, right? So if this says Santa does not exist, you're saying I reject that Santa does not exist, which means Santa exists, right? So if it's not the case that P, right, that's double negative, and we get to cancel that out and just get P alone. And that rule, that's all that negation elimination is. Anytime you have a line that has two tildes, you get to just wipe them off. That's all that the rule is. Anytime you have two tildes that are adjacent, they're not separated by like parentheses or something like that, you just get to cancel them out. Just like in math with negative and negative, you get positive, right? So so there's really nothing more to this rule than if you ever see two tildes or two negation symbols on some sentence, one applying to the other, then you just get to cancel them out, and that's just negation elim. All that you're citing is the single line that had the two tildes. Okay, so I'm spending a lot of time on this. Hopefully it's clear, so I don't need P on a new line. I already have it in the premise. Or no, I already gave it its new line, I should say. And then just from having these two on my conclusion, all I'm going to do is say, oh, you want me to show you why you believe P and Q? Well, right there, you believed Q, and right there, you believed P. And with the and intro rule, all I'm doing is sticking them together, right? So that's a super simple proof. If it didn't seem like it when I started, it definitely should seem like it in a week or two when you've done a lot of these. Okay, so let me go ahead and get to the next one. Okay, So for this one, now set aside negation elimination, right? Super simple. Just if you ever have two tildes next to each other, two negation signs next to each other, not separated at all, you get to cancel them out, no problem. And now let's talk about negation introduction. So again, when you look at the premises, you don't have an and that you can eliminate. You don't have an or that you can set up your proof by cases from. And even the tilde, it doesn't have a partner, right? I can't do negation elimination here because the only time I can ever do negation elimination is if I have two. I mean, it's really no critical thinking necessary here. Do you have two negation signs? No, you can't do negation elimination. It really shouldn't be a question. Negation elimination only ever works by canceling out. Think of it as just the double negative rule. That's how you should be thinking of negation elimination. Okay. So really the premises aren't giving us any idea of how to go forward, except just to say, hey, you can't come here. You should probably look at the conclusion. Then when we look at the conclusion, we see, okay, this has a negation. So because there's nothing to do with the premises, we need to set up a negation intro in order to get to this sentence. This is something we can talk about as time goes on. If you do ever find yourself just without anything to do in the premises, negation introduction is actually something that will always work. So because we found there's nothing to do in the premises, I'm going to do a negation intro. It'll in fact work when you're trying to prove a sentence is true, but we can talk about that maybe in this video. So for this, the idea behind negation introduction is based on those premises. We should know that that conclusion follows. So let's first just make sure we're clear on that. Because A is not true, that's premise one, and because B is not true, you should believe that conclusion, right? And if you don't, that might be because you're not fully understanding what the conclusion says, right? So that conclusion is saying it's not the case that both A and B are true. Okay, this isn't saying neither A and B are neither A nor B is true. It's saying, so this sentence, the highlighted portion, is just A and B are both true, right? That thing is happy so long as it gets A and it gets B, but it needs both of them. It's saying both of them are true. So in order for me to be happy to reject them, in order for it to be true to reject that, I don't need to throw both of them away. He's wrong just in case one of them is false, right? So that sentence is only true if both of them are true, right? And so this should be just rehearsal of what we've already talked about. This is De Morgan's, right? So that sentence right here is only true if both of them are true, the conjunction. That's what a conjunction is. So to deny that sentence just means I think at least one of them fails. So because in premise one we already see, yeah, one of them fails, well, I don't believe both of them, so you do not believe both of them. That's literally what this is saying. Do not believe both. Right, okay. So that's just De Morgan's. If you're uncomfortable with De Morgan's, that's a slightly different topic, but it's good to touch on that throughout. Okay. But as we said, the premises aren't really giving us any idea of where to go from here. So what we're going to do is we're going to say, all right, you don't believe that the conclusion follows from the premises, so let me do another hypothetical. This is just like what we did in the or elimination stuff in terms of a hypothetical, but it's going to have a slightly different structure. So we're again going to just for the moment pretend that he's right. Pretend that the person we disagree with is right. Pretend that our conclusion is wrong is the idea. So we're trying to prove that A and B aren't both true. So we're going to say, well, okay. Suppose that they are both true. Suppose that the opposite of my conclusion is right, just for a moment. And then the idea here is I want to show you, based on all of this, based on assuming that I'm wrong, based on assuming the opposite of my conclusion, I'm going to show you that you're crazy. That's honestly what we're going to do. We're going to show you that if you did try to suppose that my conclusion wasn't right, then I'm going to show you, based on assuming that I'm not right, you're going to be crazy. And so the only thing that, or the only alternative we have is to turn around and say, okay, then it's not the case that my conclusion was wrong. Right? If assuming my conclusion is wrong leads you to being crazy, then you better turn around and say, okay, all right, then your conclusion must have been right, right? If believing this thing reduces to absurdity, then you should turn around and not believe that thing, right? So that's all we're going to do with negation introduction. So this down here is going to be justified by negation intro. And again, notice what I did that's similar to the or elim. I set up this entire subproof without actually trying to work out the middle of the subproof, right? And this is what I want you guys to get in the habit of every time. When you see that you need to do one of these, oops, I chose the wrong one, negation intro. When you see that you either have to do or elimination or negation introduction or conditional introduction, which we haven't gotten to yet, then you should be setting up that entire subproof from the get-go. Because that's, as soon as you know you're doing that thing, you should know all of these little details. In order for you to actually understand what you're doing, you should know that you need all of these details. And that's just going to make it easier. I just made this proof much easier. Now all I need to do is get from premise 1 and 2 to some sort of along with this assumption, just to some sort of contradiction. We'll talk about that in just a second. But the idea here is I already have put in what my rule is at the end. I've been getting a lot of emails and a lot of questions about, wait, I set up all my stuff so perfectly and it all looks great, but then at the very end, people don't know what to cite. And that's because you're not doing that. Because you're saving it for the last. You should do that literally the first thing you do. As soon as you know that you need these subproofs, put that rule in. Tell yourself the structure of your entire proof. Don't save that for the end. You're just forcing yourself to literally redo work you've already done. Already, you've known to do this rule, so don't make yourself refigure out that you need to be using this rule. Okay. Now with that, all we need to do is figure out, how do I get from some assumption to show that he's crazy? Okay, and this is what's going to require that we talk a little bit about contradiction introduction. So contradiction, right, is that symbol. Where did it go? Why is it not showing up? That symbol, sorry. Right, and it's just an upside down T. You can think about it as truth has been turned on its head, right? So contradictions are things like snow is white and snow is not white, right? That as a whole is a contradiction, that you both believe snow is white, but then you don't believe snow is white. Or if you said Santa exists, but I also don't think he exists. Or if you said it's raining outside, but I don't think so. That's all contradictions. You shouldn't say it is raining outside, but I don't believe it. Well, so is it raining outside, or is it not raining? Right? That's the point of logic, is we're trying to sift through all of these propositions and make sure we don't believe something and reject it at the same time. So if we can show that believing this reduces to believing something like stuff on the one hand, and then that same stuff, but just the opposite of it, right? If I can show that you believe one sentence and you also believe the opposite of that sentence, that's me showing you that you're crazy. If I can show you that you both believe Santa exists, and then later on you told me Santa doesn't exist, that's you believing a contradiction. If you believe you live in a house, but you also believe you don't live in a house, that's you believing a contradiction. So all we're going to do is we just need something of the form stuff, and then that same stuff, but with a tilde on the outside, right? And so this shouldn't be too hard to find. So first of all, with our assumption, what's the first thing we should be doing? And this goes back to the first video I made. Well, the main operator is an and, so let's rip that apart to its raw materials. Okay, and then both of these are going to be and elimination. Right? And now, take a second, pause the video, and ask yourself, can I find something of the form stuff and not stuff? Because if I can do that, then that's when, let me throw away that symbol up there, then that's when I'm just going to say, okay, that must mean that you're crazy. And then all that I'm going to point out is I'm going to say, oh, well, look, here and here you believe stuff, then you believe not stuff. So really, in this case, I can find, again, pause the video if you want to find it yourself. A, you believe that on line 4, but then on line 1, you started off believing A wasn't true. So the point is, here you have stuff, here you have not stuff, right? And so it's those two lines that contradict each other. And so, right, you can either delete all the in the middle lines, or you can just get a new one. I guess I'll just go ahead and I'll just put it up here. Doesn't really matter. So the point is, there you go, that one too. I can get to a contradiction symbol. I can introduce this symbol. So anytime you're doing contradiction introduction, you're saying I found stuff and I found not stuff. And that's how I know that you're crazy, right? And then look how this rule works. So oops, let me scroll all the way down. Look how the negation intro works. So if you haven't noticed this, you can just hover over and it'll give you the structure of the proof. So if you want to prove not P at the end of the day, then you assume the opposite, you assume P, and then you just have to show them they got crazy, and then you end the subproof right there, and you say, okay, then obviously the opposite was true. Obviously not P is the case. Assuming P led you to craziness, therefore not P. So that's all we need to do right here. We just need to throw away all of these extra lines, right? All we're doing is we're saying, so negation intro. So for us, what's P, right? You need to be thinking in this sort of like structured mindset. For us, P is just A and B, right? We're trying to prove not P, so that's not A and B. And so we're assuming P, A and B. And then all we're trying to do is from that assumption, A and B, we're just trying to get to that contradiction symbol. And once we get to that contradiction symbol, you are done with a negation introduction. All you do is you just get to that contradiction symbol, end that subproof, and then you get exactly what your conclusion is on the next step. Okay, so again, let me just say that one more time, hopefully smoothly and quickly. And I guess this will give me an opportunity to say, when I'm citing this negation introduction, I don't have to cite anything other than this subproof. Why do I believe that it's not the case that A and B are both true? All I'm doing is reading the conclusion. Well, because when we did this story, when you did believe that A and B are both true, that led to craziness. And so that alone tells me you should not believe A and B. Now, notice we did use premise 1. I guess we didn't even have to use premise 2. So premise 2 was extra. But we were allowed to use premise 1 in the subproof. But still, at the end of the day, it was just the subproof that does all the work for us. And that's always the case for negation introduction. This is just like or elim. You should always just be saying, okay, let me find that disjunction in the two subproofs. For this, you're just saying, oh, let me find just one subproof. This is even simpler than or elim on what to cite. It's always just the subproof that started with the opposite and ends with a contradiction. That's what you cite for negation introduction. Okay. Now for our last one. So for that one, we've not only talked about negation elimination, but also contradiction introduction. For this one, we're going to use both negation elimination and negation intro. Excuse me, for this past one, we talked about negation intro and contradiction intro. The first one was negation elimination. For this one, we're going to talk about both negation rules, negation elimination and intro. And we're also going to talk about contradiction elimination. I believe that's going to pop up. Okay. So again, what can we do? Well, first, you can notice you have at least two tildes sitting next to each other. So what does that mean? Well, just think about this as just its own sentence, just some sentence S or whatever, just in terms of You want to be thinking about these in terms of just blocks, right? These just two tildes are on just some sentence. So these two tildes you're able to cancel out. It's the same thing if they were attaching to any other sentence. It could be not P, it could be S like I just had, it could be Q or R. The point is having two tildes on the outside means you can cancel those out. So when I cancel those out, I have one tilde left, right? It just means you take two at a time off. That's all that negation elimination is doing. So again, don't overthink this rule. Super simple rule. Anytime you feel yourself doing a negation elimination, you should just be citing how many lines? One. And you should, in that line, better have two more tildes than the one that you're getting. Right? These are all just mental checks that you should be giving yourself in order to make sure you're doing this right. Okay, but then at this point, it's not clear what I can do, because now I just have a single tilde on this line, a single tilde on the outside of this, right? The main connective here is the tilde, is the negation. And then this or is trapped inside the parentheses, so we can't do any sort of or elim, right? So now, like I said before, when you hit that wall, well, what you can do always is just proof by contradiction, which is another word for just negation intro. So let me, what I should have done in the beginning, skip a bunch of lines and put my conclusion in the front or at the bottom, because that's always how we should start the proofs. And then again, I'm saying there's nothing more to do with the premises. So what? So instead, we need to be thinking about introducing this negation. So let's go to the negation intro rule. Let's see, will it hover there? Yes. Okay, so negation intro just tells me, all right, if I want to prove the conclusion not stuff, I just need to assume stuff, and I need to get it to craziness. All right, that's all we're going to do. Let's do it. So keep that in mind. What's our stuff? We're trying to, so I'll hover over this again just to show you. So we're trying to do, we're trying to prove not stuff, so we need to assume stuff. So in our case, we have not stuff, so we need to assume stuff. And of course, Control V isn't working. So, right, we're just assuming the opposite of our conclusion. And then we're going to skip a bunch of lines. And what's the thing that we want to get to at the end of this proof? Well, if you forgot, just hover over the rule again. Stop overthinking this. Hover over the rule. Okay, I started from stuff. I'm trying to get to contradiction symbol. Therefore, that should just be contradiction symbol. Simple as that. And now it's just about how do I get from here to here? And one more thing that I have to do, I should just go ahead and cite the subproof right now. Now, this bottom line is already checked off. I already have the general structure of my proof ready. I already know that that last line is going to work. Now all that I need to do is just get from this stuff, P or Q, to some sort of contradiction. And I can also, of course, use my premises up here. Okay. The first thing some of you might be saying is, okay, well, all right, so I remember you want to get to a contradiction symbol, so the only way you can do that is contradiction intro. So look at what that means. That means we find stuff, and we need to find not stuff, and then we get our contradiction. Okay. Can anyone see any contradiction? First thing you might be thinking is, wait, I see you got not P right here, and then you got not P right here. Aren't those contradictions? No, stop it. Those are not contradictions. In fact, those are like the farthest thing from contradictions. Those are the same exact sentence. You got sentence 3, show step numbers. You got sentence 3 from sentence 1. It is so weird when I see this on the tests, or in any sort of proof, when somebody does a double negation to something, gets a new line, and then calls those two lines contradictory. Like that just shows a pretty significant misunderstanding of what's going on. The only reason you're able to do the double negation is because 1 and 3 are saying the exact same thing. They're both saying snow is not white. One is saying it's not the case to reject that snow is not white, or it's wrong it's wrong that it's wrong that snow is white, and the other one's just saying it's wrong that snow is white. But the whole point of the rule is just that canceling those two things out means we have the exact same sentence. So you should definitely not be thinking 1 and 3 contradict each other, right? Two things contradict each other when they disagree by exactly 1 tilde. If they disagree by 2 tildes, they're not contradictory. They're actually the same exact thing, right? It's just by 1, it's the opposite. By 2, it's the same. By 3, it's the opposite. By 4, it's the same. By 5, it's the opposite. By 6, it's the same, right? So now I have the opposite sentence. Now I have the same sentence again. Now I have an opposite sentence. Now I have the same sentence. Now I have an opposite sentence. Now I have the same sentence, right? I'm just turning off the light switch on or off. What is the proposition true or false? So here, both of these sentences, 1 and 3, are both calling P itself false. So that was a lot just to say, don't ever, you need to be very careful on what is a contradiction. It just disagrees by 1 tilde and 1 tilde alone. So we can't do that. So we can stare at this and stare at this and stare at this and try to figure out what to do. And you're going to run into another brick wall. So, well, we don't have any and still. We don't have any more things we can do a negation elimination from, right? We already did it to 1, so there's no point in doing that again. So now what do we have, though? We actually have an or. So how do we work with ors? We set up a proof by cases. And so this gives me an opportunity to show you something that's slightly more advanced, but something you're definitely going to need to feel comfortable with. You can do these rules at any time. You just need to be careful at when you do them. So right now, we're going to set up a proof by cases. And we just need to be clear on what we want out of this proof by cases. Okay, so we're going to first, so if we have a proof by cases, then we have 2 subproofs. P, and then I'm going to end that subproof, and then start again. This one's going to start with Q. And then I just want both of these. Where am I trying to get with both of these? With both of these, all I'm doing, I'm not looking for the conclusion anymore, the conclusion of the entire argument. I'm looking for, at this moment, while I'm inside this subproof, I'm just looking for the contradiction symbol. So I'm just going to obey. The rule says, hey, whatever it is down there, I need to put it up here. So the idea here is I'm showing how, regardless of if P is true or if Q is true, I'm going to get a contradiction. Okay, and so I'm going to get, so that means I know that based on this subproof, and based on this, so, right, let me start the other way. If I assume that either P is true or Q is true, well, P would lead me to a contradiction, and then I'm also going to show Q would lead me to a contradiction. Therefore, I better have a contradiction. So based on knowing either P is true or Q is true, both of those are going to lead me to a contradiction. So therefore, I have a contradiction. So right, so just to be clear, we didn't need to do these extra 2 subproofs in the first time we did the negation introduction. So this is me showing you, we're doing a whole second. That's interesting. So this is me showing you a second, this is a more complicated proof in that it requires you to nest rules together, nest subproofs together. In this case, actually, this is not going to be justified by contradiction intro. So when I said earlier, you're only ever going to get it through contradiction intro, that's only true 99.9% of the time. You can also get it through or elimination, but just recognize what's going on. Each of these guys are going to have to be gotten through contradiction intro. So that's where the contradiction elimination is popping up. And the idea is we're getting this final contradiction just by saying both of these will end there. Okay. So now we need to figure out how do we get this first subproof to land in a contradiction. So, well, you need stuff and not stuff. Here's stuff, here's not stuff. So I can delete all these lines in between. And I know I get this contradiction because you believe P here and you need to believe not P here. that's contradiction, introduction. What about Q? How am I going to get a contradiction on this end? Okay, this is also going to be slightly, or going to push you a little bit. Well, I need stuff and I need not stuff. Up here, I have a line that says not stuff. And so if I could just get this line, the highlighted part, if I could just get Q or R on its own thing, then those are contradictory, right? So line 2 is saying it's neither the case that Q is true or R is true. But 7 is saying Q is true. So if 2 is saying neither Q nor R is true, but 7 is saying Q is true, that should give you some intuition that those two things will contradict. So this requires that you understand what the lines mean. But once you do, you should see that, yep, those two lines are going to there's a contradiction that you can get out of them. Right now, they don't contradict because it's not just stuff and not stuff. You need to have them. You need to have stuff and stuff be exactly the same and then just differ by a single tilde. But if you remember, if I want a phrase like Q or R, then all I need is one side, and then I can throw the other side on for free. And here on line 7, I already have that one side, so I can just throw the other side on for free. So I'm getting that from 7, and that's just or intro. All right, and so hopefully it's getting a little bit, so on the one hand, this is probably confusing because I'm throwing in a lot of rules in at the same time. I'm talking about a lot of rules at the same time. I'm doing a negation introduction first, and now I'm doing an or intro and doing random things at random times. That's the sort of familiarity with the rules that you're going to want to build, and that's the point of doing all of this. You're going to want to have these things in your back pocket so you can say, oh, okay, here I just need an or intro. We're not going to tell you that you need that. And in fact, if you look at somebody else doing the same proof, they might be able to do the proof without using that rule. There's different ways to do each one of it, to do any proof. So make sure, so the idea here is this isn't about learning just the rote process. Oh, if I see this, I need to regurgitate here. You want to be thinking about these rules as different things that you have the power to do. You want to be thinking of these as different tools that you can use to problem solve. And that's the point of this class. That's getting you to actually think in terms of a critical problem solving manner. Okay, so now we have Q or R. And so now we can do our contradiction introduction because we have stuff and we have not stuff. And that's all contradiction introduction needs. Right, and so now we can check our proof. And what did it not like? So we have Q or R and we have not Q or R. And so what does it not like? Okay, that's all that it is. It is just, this is not actually an or, that was just a V. So now I'm going to change that to a real or. Then it's going to look. And apparently, did I do the same thing down below or something with my goal? Okay, so I know that one was complicated, so let me just just talk about it just for a second. Maybe clean up what we did here. So the first thing that I did was notice that I have 2 tildes on the outside of some sentence. There happens to be 3, but 2 is enough for me to cancel out. So I canceled out 2 of them, and I just have not P. And then I noticed that my main connectives that I'm left with are just single tildes. So I can't do a tilde in elimination or negation elimination. And I also, of course, can't do an or elimination because this is trapped within. It's not the main connective. So then I just turn around and I say, okay, I got to do a negation intro. I got to do a proof by contradiction. And so to do that, then I'm really not doing any critical thinking yet, honestly. All I do is I say, okay, I ran out of stuff to do with my premises. I got to do a negation intro. And so I'm going to go put this rule in, and I'm going to hover over it, and I'm going to see what it tells me to do. And it tells me if I want to prove not stuff, I got to start a subproof with stuff, and I got to end on the contradiction symbol. That's exactly what it tells me to do when I hover over the thing. It tells me to start with stuff, get to a contradiction symbol, and I'll let you tell me the conclusion, not stuff. That's all I got to do. So that's what I set up from 4 to 10. And then I forget about doing a negation intro. I already cite those lines. I do all of that stuff. And now I'm not going to try to make sure I know which line. I'm making sure I click what this is justified by, and I'm making sure I put the rule in right now, because you don't want to try to make sure you can refigure it out at the end. Now my only goal is just trying to get from P or Q plus the premises to some contradiction. That's all I care about doing. I don't care about what's going on down here anymore, because it just doesn't make a difference. All I'm trying to do is, this is my new conclusion. Now, how do I get to it? And this is a new premise I can use. So how do I use it to do that? Okay. And then I just think, all right, now basically I have 3 premises. I have this one, not Q or R. I have not P, which is the same thing as 1, but it's simpler. And then I have P or Q. Okay. Again, I can't do any and elimination. I can't do any or elimination with the first 2, but I can do an or elimination with the second one. And so when I'm doing that, I'm just, okay, now within this subproof, everything's happening within this subproof now. I'm just going to set up my proof by cases. And so now that's how I know I'm going to get to this last line. So if I'm doing an or elimination, it's already selected. So I could just, all right, I'm doing or elimination. Tell me how to set it up. So if I want to get to this conclusion S, I need to start with some or at the top. That's my P or Q. There's just P1 or Pn, for however many ors you have there. And then I just need to have 2 subproofs, one starting with P and ending with that conclusion, and one starting with Q and ending with that conclusion. Okay, I'll do that. So then I just put in 2 subproofs, one starting with P, ending with my conclusion, one starting with Q, ending with my conclusion, right? Again, none of this has been like super critical thinking. I'm just realizing I can't do anything at certain points, and the only thing left for me to do is first, the only thing left for me to do was the negation intro, and now the only thing left for me to do is the or elim. And now all that I need to do, once I've set up my or elimination, once I've made sure that this thing is justified and I don't even have to even look at it again, I just say, all right, how do I get my 2 subproofs to work? The first subproof should be really easy. Trying to get to a contradiction symbol, I just need stuff and not stuff. Well, I already have 2 things that are directly contradicting each other. Okay, done deal. Done with the first subproof. Now I just need to worry about getting the second subproof to work. This one requires that you remember, and this one requires that you have a better familiarity with the rules, definitely, because you need to be first knowing that you're looking for something and then not that something. And then so you have the not something up here, and it's important, and it just requires that you remember, if I ever want a disjunction, it's good enough just to have one side already. So you already have one side of that disjunction. You can build the rest with or intro, and then you get negation. Then you get this contradiction. Right, and so that was the entire proof, right? It was really only this second subproof was the only thing that I did that was, I would say, kind of hard. Other than that, all that you're doing is really just following directions. You're really just seeing, oh, I can't do any of my elim rules other than the negation elim originally. So let me do the negation intro. And then the only thing left for me to do is the or elim. Let me just set that up. And setting up these subproofs should be increasingly straightforward, because all you're doing is just asking, oh, what do you want me to do? What do you want me to do? Oh, you want me to do that? Okay, I'll go do that. That's all that you need to do. Don't overthink it. Don't overthink it. Okay. So each of these hopefully gives you a little bit better idea of how these rules work. Negation elimination, basically as simple as conjunction elimination. In terms of, you're just taking one line and deleting 2 different or 2 tildes from it. Negation intro, that's slightly more nuanced. That requires you to start a subproof where you assume the opposite and get to a contradiction. And then finally, in this proof, we did both. We did negation elimination and negation intro. What we did not touch on is contradiction elimination. instead of just dragging out this video, I'll just say briefly, what contradiction elimination does is, let's say we did want to get to some conclusion S down here. And let's say in this subproof, yeah, we got to S just fine. But in this subproof, all that we were able to do was, hey, I mean, so yeah, Q will lead to S, but then P, I don't know that it'll lead to S. But the thing is, we already know P is false. So, you know, P or Q, you're trying to get to some conclusion S. And, well, you know Q will lead to S somehow, right? Like, just imagine. And it's just about, oh, well, I mean, I don't actually know P will. But up here, you've already pointed out, well, P isn't true anyway. So the idea is, if you have a contradiction line, then you know, oh, well, then this guy believes anything. I mean, that's more or less honestly what's going on. If somebody believes a contradiction, you can logically prove that they should believe absolutely anything you want. So contradiction elimination just says, if you can get somebody to a contradiction, on the next line, you can just throw in exactly whatever you want, citing that contradiction. And then Control D. Then down here, I can actually check just that line and it's happy. If you check the whole proof, now you're going to have problems because S didn't actually occur in the proof. But just hopefully this gives you a sense of what the rules are looking for. Me checking just line 11 right here is it's just asking, all right. You're trying to tell me you can get S from 4 and then these two subproofs. 4 is telling me P or Q is true. And then this subproof tells me, well, if it was P, then you're going to get me S. This subproof is telling me if it was Q, then you're going to get me S. So then you get S. So I know that I'm throwing a lot more in there. So please rewatch this just to grow that understanding. Or if you're totally bewildered by it, feel free to just not watch this part and cut off the video earlier. And of course, email me if and when you run into issues. But hopefully this is growing your understanding and ability of working with these proofs as tools and seeing how they'll fit together a lot more. Okay, let me know if and when you need help.